Yesterday you went through and did your Pythagorean theorem, and then today we're just doing more Pythagorean theorem, and we're doing what's called Pythagorean triples.
What?
Okay, so yesterday we did Pythagorean theorem. Remember, a squared plus b squared equals c squared. Okay, remember your a and your b are your lengths of your two legs. So your two shorter sides of your triangle, and then your c was your hypotenuse. Yep, hypot.
Oh my goodness.
That's just because hypotenuse is a really long word. Okay. So we're looking at what's called the converse. That just pretty much means you're looking at what it equals first and then comparing what you're adding. So it says, you previously learned that the two sides of a right triangle, remember your Pythagorean theorem only works with right triangles, are known, and the third side can be found using your Pythagorean theorem. Okay, also if you're given your hypotenuse and a leg, you can also find your other leg using your using your Pythagorean theorem, so just kind of keep that in mind. Just like yesterday, Pythagorean theorem is a squared plus b squared equals c squared. Okay?
Didn't we do that in like 8th grade?
Yes. But you probably haven't seen it since then because I had to teach it in Algebra 1 like at the end.
I had it in
Yeah.
8th grade.
We taught it at the very end of Algebra 1, so y'all could have it when y'all got here. Okay, so any group of three positive integers, so just three positive integers, those are just three positive numbers, okay, such as c squared, a squared, and b squared is known as your Pythagorean triple. All that means is those are just three lengths that will always work of a triangle. Okay, so it's just three numbers that are always going to equal in your Pythagorean theorem. Okay, so it's just an easier way. Some people memorize them, some people do not. I mean, it's totally up to you. I've never had to memorize them, and I've made it through life okay. So you can always do Pythagorean theorem. Remember, your two smaller ends are going to be your legs. So 3 squared plus 4 squared should equal 5 squared if it's a triple. So what is 3 squared? 9. And 4 squared is 16. And does that equal 25? Yes. So 3, 4, 5 is a Pythagorean triple.
Is that it?
That's it.
Wait.
Yeah, you probably did. Some teachers really want you to memorize them. Some, I don't really care if you memorize them because you can figure it out using Pythagorean theorem. Okay, so your other types of triples are, you've got 3, 4, 5, which is the one we just looked at. Okay, you've also got 5, 12, 13. Okay, you also have 8, 15, and 17. And then the last one is 7, 24, and 25. Okay.
So the B's are always one.
Usually from one of them, yes. I wouldn't look for a pattern because then this one doesn't go with that pattern.
Oh.
Yeah, it just happens to be three numbers that go together for your Pythagorean theorem. No, those are different. Those are going to be later on this week. Yeah. Okay, so recall that you're given three sides. A triangle can only be formed if the sum of the two smaller sides. This is when I really need three hands. Yeah, probably.
Is it supposed to be S?
Yeah.
Okay.
So the sum of your two smaller sides has to be greater than, hold that. Has to be greater than the third side. Okay, so we did that on one of our other problems where we looked at our two sides, A plus B, and they had to equal something greater than C. So we did that just a few units back, maybe unit before last. Okay, so if we're adding our two smaller units, so 4 plus 5, is that going to be greater than 6? Yes, so those could all be the lengths of your legs of your triangle and your hypotenuse. 4 and 5, we're going to add those together. That's 9 still. Is that greater than 9? No, it's equal to, so those could not be the lengths. 4 plus 5 is still 9. Is that greater than 10? No, it's not, so those could not be lengths of your sides of your triangle. Okay, so just remember your two smaller ones added together have to be greater than your largest side, which is your hypotenuse. Okay, anybody have any question on that part? That's just review. Nope. Okay, turn the page. Okay, so we're also going to look at using your Pythagorean theorem to classify your type of triangle. So one way you can look at it is we're going to look at if it's acute, obtuse, or right. Okay, so remember that's what we're classifying due to the angles. So if a triangle can be formed, okay, you can determine the type of triangle by looking at the square of the longest side and the sum of the squares of the shorter sides. Those are just our Pythagorean theorem. So we're going to use our Pythagorean theorem to be able to classify the type of triangle that it is. So if it's a right triangle, your hypotenuse squared equals your a squared plus your b squared. Okay, that's what we've been doing, because remember your Pythagorean theorem only goes for right triangles. So they're equal when it's a right triangle. That's fine. Okay, if you're looking at an acute triangle, okay, your c squared is going to be less than your a squared plus your b squared. Okay, think acute is like smaller than a right triangle, so c squared is going to be less than your sum. Okay, obtuse, if this one is less than, your c squared is going to be greater than in an obtuse. Okay, that way then you can classify your type of triangle just based upon your Pythagorean theorem. You don't have to know the angles in order to classify. Okay, so if we're looking at these, it says determine if the triangle can be formed. So that's with our sum being greater than our third side. And if so, classify it. So first we add our two smaller sides. 5 plus 4, is that greater than 12?
No.
No, so we can't classify it. So we move on to the next one. Okay, add our two smaller sides. 6 plus 7, is that greater than 8?
Yes.
Yes. Okay, now we're going to classify it using our Pythagorean theorem just like earlier. Okay, so we've got 6 squared plus 7 squared. And we want to know what that is to 8 squared. Okay, so what is 6 squared plus 7 squared? 36 plus 49 is 85. Is 85 greater than, less than, or equal to 64?
Greater than.
Greater than. So we want our sum to be greater than. So it's acute. Okay, because this is our sum over here. Okay? Okay, same way with this one. We've got to see if it's going to work first. So is 1 plus 3 greater than the square root of 10? So is 4 greater than 3.1?
Yes.
Yes. 4 is greater. Okay.
I read it wrong.
Then we want to classify it. So we do 1 squared plus 3 squared is what? Square root of 10 squared. When you have a square root that's being squared, all that does is get rid of your square root. So 10 are blank. And then 1 plus 9 is 10, right? So if it's equal to, what type of triangle is that?
Right.
Good. Okay, and our very last one, first we want to add them to see if it's going to work. Square root of 9 plus the square root of 16. We want to know if that's going to be greater than the square root of 27. So 9 plus 4, is that greater than, what's the square root of 27?
Would it be 3 plus 4?
Oh, I'm sorry.
5.19615.
Okay, so is that greater than 5.1?
Yes.
Yes. Okay, so we can say yes, it is a triangle. Then we're going to square our sides and add them. So square root of 9 squared plus square root of 16 squared. We need to know what that is to the square root of 27 squared. Okay, remember, if you're squaring a square root, all that does is just get rid of it. So 9 plus 16 is what to 27?
Less than.
9 plus 16 is 25, so it's less than. So we need our total to be less than. So we look up here, we look at our total. We want it to be less than, so it's going to be obtuse. Okay. Anyone have any questions on those notes? How to classify, how to use your Pythagorean theorem, anything like that?
Nope.
Okay, perfect. That work?